Today we're going to talk about section 9.4, page 10. This is page 10 with the sine function and solving sine equations. So we're going to get started. Number 1 says to graph the function y equals sine of x with the domain from negative 2 pi to 4 pi inclusive. So we'll start over here with negative 2 pi, negative pi, setting up our axes. Okay, so one sine curve, when we do our period for sine, we go all the way up to 1, down to negative 1. Goes from 0 and back up. Right, so there's our one curve. Now we can continue that same curve throughout, all the way up to 4 pi, and to the left the same idea, all the way to negative 2 pi. Now when we're solving these trig equations, it's going to be important to graph more than just one period so that we can really see what's happening over time as it repeats itself. Part A says find the solutions in radians on the interval negative 2 pi to 2 pi. Notice including negative pi but not including positive 2 pi to the equation sine of x equals 1/2. So what are we looking for? We're looking for where this graph sine of x intersects the graph y equals 1/2. Well, if I were to draw that, 1/2 is right here. So I want to know, and I'm just going to draw that as a dotted line across y equals 1/2. I want to know where those two graphs intersect. Well, it's pretty obvious to see that they intersect at 1, 2, 3, 4, 5, 6 points here, but notice our interval that they gave us was only from negative 2 pi to 2 pi. So really I'm just looking at these two over here and these two right here. Okay, well, using our knowledge with unit circle, when is the sine of x equal to 1/2? So what are the x values of these intersection points? We obviously know the y values, but what are the x values? So what is this x value? When is that first x value of when sine of x is equal to 1/2? Well, we should know, right? Again, using our knowledge of unit circles, we know that that first one is at pi over 6, 30 degrees. And then the next one would be at 5 pi over 6. Okay, so how about over here? What are these two? What are those 2 points? Well, if I think about it, negative pi, and then I keep going, right? So again, using unit circle, what would that value be? That would be at negative 7 pi over 6. And then this one, almost all the way around to negative 2 pi, would be at negative 11 pi over 6. So those are my 4 solutions to this equation. So x would equal, and the way we can just write it is just as a list here, negative 11 pi over 6, negative 7 pi over 6, pi over 6, and 5 pi over 6. So in this interval from negative 2 pi to 2 pi, there are 4 x values that make this equation over here true. Okay, let's talk about question B. Find the solutions in degrees, move it down, on the interval from 0 inclusive to 360, not including 360, to the equation sine of x equals 0. Okay, well, let's go back up. And again, I'll do a red dotted line of when these two intersect. So when is y equal to 0? Well, that's just right along our x-axis. And where are the points where those intersect? Well, obviously it's here, here, it's all of our x-intercepts. All right? So it's all of those x-intercepts. But this only wanted from 0 to 360 degrees. Well, obviously that's the same as 2 pi. So from 0 to 2 pi, but it does want our solution in degrees. You're going to have to be very careful in this chapter, noticing when they say degrees and when they say radians, because they're going to give you 2 very different answers. So from 0 to 2 pi is only in this interval from here. So notice there are 1, 2, 3 solutions at 0, pi, and 2 pi. But remember, 2 pi is not included. And so that would not be one of my solutions. So really, my answers would be for 0 and pi. Let's say x equals here, 0 and pi. But it wants it in degrees. So I would change that to 0 and 180 degrees. And those would be my two solutions. Okay, let's try question C. Find all solutions in radians to the equation sine of x equals -1. Okay, this first part is very important. All solutions. So you really want to look for those words. You're going to see those a lot when you're doing all these problems in this section. Okay, so when is it equal to -1? All right, well, let's again go up to our graph and find where it intersects the line at y equals -1. And we can see there's one here, and one here. All right, again, using our knowledge of unit circle and of trig, where are those values at -1? Well, that's halfway, right, between pi and 2 pi, and so this one would be at 3 pi over 2. This one over here would be at 7 pi over 2. Is that right? Right. This one over here would be at -pi over 2. Well, how would I find all of the solutions? No. So that's what I'm seeing here, right, is in this interval, it was -pi over 2, 3 pi over 2, 7 pi over 2, etc. In the past, we've talked about that. We've just done the ... dots. We talked about etc., and it just keeps going. But what we want to get into now is the habit of writing these with the k, that where k is an integer. How would I rewrite this? So the way we're going to rewrite it is you're going to take the answer from that first period, from 0 to 2 pi, that first period, take that answer, 3 pi over 2, and then we're going to add one revolution. Well, one entire revolution is just 2 pi times k, where k is any integer. Remember, z's are just the integers. Okay, where k is any integer. So that makes sense. That could be integers are positive and negative, so that means I would go to positives or I would go to negatives. If I were to add 2 pi to 3 pi over 2, that gives me this first one, 7 pi over 2, add another 2 pi, add another 2 pi, etc. This will then generate all of the solutions like it asked for. Anytime it asks you for all solutions, your answers will have some sort of plus 2 pi k, plus pi k, plus something of this nature. Let's try a similar question here, but in degrees now. So find all solutions, but this time in degrees, of when the sine of x is equal to root 2 over 2. Okay, well, root 2 over 2, we know by our knowledge of unit circles, and again, we could look at it up here on the graph as well, that x is going to have to be at pi over 4s, right? It would also be at, in degrees, that would be the same as 45 degrees, right? So we know, and we could keep going, when is it equal to this? Well, it would be at 45 degrees. But there's also another one. Let's go up to our graph here. There's going to be 2 answers in that first period. So for root 2 over 2, right, that's going to be up here. And so when I go across, right, root 2 over 2, is that bigger than 1/2? Am I right here? Yeah, so root 2 over 2. When I go across, I'll write it down here. It's hard to see this, I know, but root 2 over 2. Again, there's going to be lots of solutions. 1, 2 here, 2 here, another 2 here, and it will keep repeating itself. These are the 2 we want to look at, though, in the first quadrant, right? I'm sorry, in the first period. So in this first period, that one would correspond to pi over 4. And then the next one would correspond to, where would that next one be? After pi over 4, the next value that gives a sine is equal to positive root 2 over 2 would be at 3 pi over 4. I know that's hard to see. So let's go down and see what we write. So what am I saying? I'm saying it's at pi over 4, 3 pi over 4. But again, this wanted it in degrees. Whoops, sorry, you can't see that. There we go. Pi over 4 and 3 pi over 4. In degrees, though, so this one would be 45 degrees and 135 degrees. And then it goes down, and then it would repeat itself and repeat itself and repeat itself. For each of these 2 answers, though, I have to rewrite them for all solutions, so I have to give them the plus 2 pi k. But this time it's degrees, so it'll each one be now, instead of 2 pi, 360 k and 360 k. So these would be my 2 solutions, and again, where k is an integer. Okay? That's it for page 10.